So this is our ICP 6. The first part we did was remove outliers from garage areas. So you can see we have a bunch of zeros down here and some other miscellaneous values. We removed the outliers. We have no more zeros, and we removed some of the outliers at the top. Next, we plotted an attribute with a regression line. Since we already removed the outliers, we decided to just use the same data set. So here's the regression line for that garage area attribute, and you can see the data kind of trends upward in a diagonal pattern, which is what this regression line captures. You can also use our linear regressor to predict some values. So that's what we did here just to show. Next, we created a data frame with the 5 most correlated attributes, and we created dependent and independent variables. So our dependent variable is sales price. We split that data, created a linear regression object, and then predicted those values. And then a similar thing down here, we took all the numerical data and created dependent and independent variables, split those using test train split, imported PCA and a standard scaler because PCA data needs to be scaled, fit transform on the scaler. And here we're using a number of components equal to 0.75, which basically means that the PCA object will choose the number of objects that explain 75% of the data. So in this one, we're using 16 PCAs, fit the linear regressor object, and again, predict those objects. So let's see how the two values did. We see the mean square error with and without PCA, the MAE, the RMSE, and the R squared. So I believe in all of these metrics, the PCA scored just a tad bit higher than the MSE. And that's because we have a lot of dimensions, and we want to capture as much of that data as we can. And we can do that through PCA. Okay.
All right, and then for question 2 of this ICP, we were given a data set called credit card. Here we import all the libraries we're going to use, and then we read in the CSV, and then we dropped CUST ID because it was irrelevant to the data. And then we get the shape, and then we saw all the null values and how many there were in each column. And then for each of the column with null values, we filled in with the mean. And then we printed out the null sum again, just to make sure that we got everything. And then here, we fit the data, and then we made using the elbow method, we predicted the inertia, and then we got the number of clusters. And then with the number of clusters, we fit the data, and then we predicted how the clusters, and then we printed the silhouette scores for how well we clustered the data together. And then using PCA is the second part of the question. We made a heat map to check on all of the correlations. And then scroll down. And then we scaled the data, and then we fit it. And then we used the k-means as again and then we predicted, and then we got the silhouette score, and then it was 0.209, so it is worse than before. And then we used PCA, and then we used k-means again. And then we predicted, and then the silhouette score was better than when we just standardized.